Okay, hey everybody. Okay, we are going to be working with exponential graphs, and these graphs are either going to be that of growth, meaning as you read left to right, the graphs are going up, or decay graphs, whereas you read left to right, the graphs are going to be going down. And look at what you notice here. When you have e to the x and 2 to the x, so an integer or the constant e to the x, you have a growth graph, right? In a few minutes, you'll see what would constitute a decay graph. But this is what the parent graph looks like. All of them start right there at the point 0, 1, because e to the 0 is 1. 2 to the 0 is 1. So when you plug 0 into the x, any non-zero number to the 0 power is equal to 1. Right? So that's what the parents. These right here are the parent graphs of e to the x and 2 to the x. But this says this has a scaling factor by 4. This one has a scale factor by 5. So all that means is whatever each of these points are, if you multiply it by 4, what's going to happen is it's going to get steeper even way faster. So when there's a number out here called a scalar, a number that's being multiplied by the function, if it's an integer, the graph is going to grow more rapidly. All right, I'm going to pause this and we're going to look at a decay. Okay, and what I forgot to mention ago, in the parent graph, there are these asymptotes where y is equal to 0, there is a horizontal asymptote. That's just on the parent graphs of these. Okay, now look at what we have. We have fractional bases. Remember, the number that has the exponent, that's called the base. When the base is an exponent, the graph is going to look like this. This is y. If we put a -4 as an exponent, well, remember, a negative exponent says do the reciprocal, so that then becomes e to the +4. We flip this if there's a negative exponent. So if we put -4 here, that would be 5 times 2 over 1 to the +4. And now that these are integers again, you can see that the graph would be doing this. And again, if there's a scaling factor multiplied by 4, the graph is going to be steeper this way and come down more sharply. Oops. And these are called decay. So for example, sociologists that study kind of large groups of people and behavior, sometimes small groups, but usually large groups of people and behavior. Well, when sometimes there are world events that happen, it could be crime, it could be just technology growth, societal changes. There's sometimes large cities start to see population declines. And when they do, when people are moving out of the big cities, this is what these exponential functions are typically used to model that behavior. Okay, now we're going to work on growth functions where it has been transformed. So a table of values is always a good idea. Always go ahead and start with the horizontal asymptote where y is equal to 0. Start there, and then let your eye be drawn to the number that is being added or subtracted not to the x's, but just on the outside of the exponential. Since that's positive 2, we'll move this up 2, and that starting point of 0, 1 will get moved up 2. All right? The next place to draw your eye is, notice we're starting right here where the x's are 0. Well, just like on polynomial graphs, whatever zeroes out, so see, notice how that says 3x plus 2. Whatever zeroes out, the x plus 2, well, that would be negative 2. So this dot now is going to be moved back negative 2, and you're ready to draw that graph. But here's what you need to keep in mind. It's going to be a bit steeper. So instead of it doing this, it's probably growing a little bit faster. And I don't know, I may have made that start growing a little bit too fast. And if you want to know, if you want to know where the values are exactly, so you're not guessing or so you're not way off, you really should be doing a table of values. So the middle value right there is whatever zeroes out the exponent. So in this case, it was negative 2. And then just with your calculator, you're going to type 2 times 3 to the caret, put a parentheses around it, negative 2 plus 2, parentheses, and then plus 2. And so what you're going to get is, I believe, 4. Oh, let's see. So this was here. That goes up 2. Oh, and the reason why that is up 2 is because twice as steep. So yes, that dot, even though we raised up to, remember, 2 times 1, so that's going to be raised up 1 just like that. Sorry about that. That's why the table of values is helpful, because it's easy to mess this up. And then go 2 to the left, 2 to the right, and then get your values to know exactly how steep this is going to run. All right, and we're going to come over here and start this process again. So let your eyes be drawn to, where does that horizontal asymptote get moved to? Up 2. So the dot gets moved up 2. That's going to have a scale factor of 5. So go ahead and count up instead of 1. Whoops. Instead of, remember we were here at 5. The scale factor of 5 would be up here at 5, and then we move up 2. There you go, just like that. All right, so, and then notice what zeroes out the exponent piece? Negative 1. So that's going to be the middle value, and we're going to put that dot right there. And then when you put all that information in, we should be at a height of 7. There, I did that one correctly this time. And then this graph, there's a scale factor. Notice it's growing rapidly, but you would do your table of values, and that's just a calculator keystroke thing to figure out where things are. All right, that is it for exponential graphing.